All right, so we're talking about chapter 4, percentage today. We'll first remember the last couple of classes we talked about the decimal and also decimal fractions. So first we'll look at how we can convert any decimal to percentage. Now look at these examples. It's actually very easy. If you have a decimal fraction, all you do is just move the decimal point 2 places to the right. Okay. Just assuming, for an example here, 0.7. So we assume we have, infinite number of zeros in the right side. So you can move the decimal point just 2 positions to your right. Just like, for an example, let's say you have 0.6 and you assume there are, as many zeros as you think you have, since you have infinite zeros, and you move the decimal point to the 2 positions to the right, that becomes 60. And you also put a percentage sign. Okay? Now, so for every decimal fraction, we can do that. Now, here are some backward examples. Like if you are given the percentage sign, you can move the decimal point 2 positions to the left, which will convert the decimal fraction, I'm saying the percentage to the decimal fraction. Okay? Similarly, for an example, and also remember, when you move to the left side, you can always assume there are infinite number of zero in front of number, because no matter how many zeros you add in front of the number will still remain same, right? So you can assume that. Let's try. Now, this is what we have now. Remember, we know how to convert between fraction and decimal fraction, right? Remember, the fraction has numerators, denominators, right? And we can divide those to get, for an example here, we can divide 125 by 1000 to get the fraction, decimal fraction. And let's say this is your decimal fraction. You can always just move the decimal point 2 positions to the right to make it percentage, right? So, if you know 1 out of these 3, you should be able to find the other 2. Okay? Let's look at a couple of examples. Let's say we have 33%. What is it in, can you find the decimal for this one? What is the decimal point here? It's just right after the last 3, right? And we move it 2 positions to the left here. Let's make it 0.33. So the right answer is C, right? 5%. You have decimal point right after 5, and you move it 2 positions to the left, because you can assume there are zeros here, right? So it's 0.05, so the right answer is C. 110%. So you have decimal point here. You move it 2 positions to the left, which makes it 1.1, right? Which is B. Now let's try some fraction, decimal fraction, to make it percentage. Remember, the percentage numbers will be larger, right, compared to the decimal. So you move the decimal point to the right. It's 0.15, you move it to the 2 positions to the right, which make it 15. It's 15%. Right answer is D. Okay. 0.75. You move the decimal point 2 positions to the right, so your decimal point should be here, right? Which makes it 75. So the right answer is A. How about 2? Just a whole number, right? So you have a decimal point here. You can assume there are, infinite number of zeros after this 0, right? Because after the decimal point, if you add as many zeros as you want, the number still remains same. So you just move the decimal point 2 positions to the right, which makes it 200. So the right answer is C. . This is 1. Again, you have decimal point right after 1. If you move it 2 positions to the right, which makes it 100. So right answer is 8. Right? %. The decimal point is here, right? And you move it 2 positions to the left, which makes it 0.25. But look at this, you have to actually make it to a fraction, right? So the idea is you first make the decimal fraction, right? Then you can get into fractions. So 25% is actually 0.25. Now how do you write 0.25? It's 25 over 100, right? Remember, from the fraction to decimal fraction. Now you can cancel out the prime factors. We learned it, right, last class, couple of classes. 5 times 5 times 1, and now you can write 5 times 5 times 4 times, right? So if you cancel out 1/4, which will be the lowest term. So the right answer is 1/4, right? If you just 25%, make it 0.25, and then from there you get 25 over 100. You simplify it to get the lowest term, which will make it 1/4. Another example here, which is 50%. If you follow the same step, it will be half, right? Which is C. Here is an example. 33.3% is 1/3, right? Close to 1/3, so that's the right answer, D. 300%. So how do you convert it to fraction? Okay, let's say I want to go to, so I actually move the decimal point 2 positions to the left, which makes it 3, right? So that means it's actually 3/1. I'm saying 3/1 is actually 3, right? So because if you have a whole number, your denominator is always 1, right? The right answer is B. We can always write 3, but just to show you that there is a denominator which is 1. Now, let's see how we can solve some word problems using percentages. To solve word problems, you will have 3 components. One is the base, which is actually a number, right? And most of the time in the question, you will see the base will be followed by of, the word of, okay? And there will be a portion which is the fraction of the base. Now remember, one thing most of the people get confused when I say a portion of the fraction, they might think that since I'm saying this is a fraction of the base, it is lesser always. It's not always lesser. It may be also greater. It depends. Maybe also greater. Okay, we'll see some examples. And the rate, which is the last one, which is the percentage. Okay. Now, what happens is when you are solving a word problem, you will be given out of these 3, you'll be given 2. Okay, and you have to find the third one, which is unknown. So the main problem is you have to identify which is unknown, which you don't know, and then you just plug the formula and which is easy. Okay? So the important part is to identify which is unknown. Either it's a base or it's maybe a rate. Identifying the rate is easy, but portion and base sometimes is a bit confusing, but it's easy if you just do a little bit of practice. So again, we just want to identify the quantities and then find the formula. And here are the formula. This is actually the same formula, but we just tried to write it in different format. here the B is base, P is portion, and R is rate. So whatever the unknown, you will be using the formula, keeping the unknown as the left, at your left, right? For an example, if you don't know the portion, you will be using the first formula. And then if you don't know the rate, middle one. If you don't know the base, last one, right? Again, this is actually the same formula, but we wrote it in different format. So, and on one more thing is, whenever you use these formulas, okay, the rate should be always plugged as a fraction, not as a percentage, because the rate is actually a percentage, right? 5%, 25%. But we know just we can just write percentage as a decimal fraction, right? So we'll always plug the rate as a decimal fraction, and even when we are getting an answer as a rate, it will be coming as a decimal fraction. Then you will convert it to a percentage. Let's look at a couple of examples. Now here's an example. What percent of 120 is 24? If you look at this example, you must see that the 120 is followed by off, which should be the base, and 24 is another number which is portion. So you are looking for actually rate. Now look at the formula. This is what we plug in, right? This was the formula. Remember, we had three formulas, and this is the formula for the rate, because the rate is at the left side. And we plug the base and the portion, and get. Remember, as I said, when you get the rate, the answer will be coming as a decimal fraction. This is what we have, and we convert it to a fraction, to a percentage, moving the decimal point 2 positions to the right, which makes it 0.2 equals to 20%, right? Any question here? Another example. Again, a word problem. A box of 240 screws was used to install drywall. Now, if the job is 75% complete, how many more screws you need to finish the job? Now, first of all, you probably want to identify what is 240 here. As I said, it's a bit confusing because identifying 75% is easy because that's rate. But if you look at the problem more closely, you'll see that the 240 screws they used, that is not the total screw they need. This is actually the portion of the screw they needed, right? Because they did not complete the job. You see what I'm saying? So that's why 240 is actually a portion instead of a base. Then we just plug the formula for base, and also notice that, as I said, the rate is always plugged as a fraction. So we wrote 75% equals to 0.75, and this is our rate. We plugged it here as a 0.75. We got 320. But if you read the question again, you'll see that they just don't want to know how much is the total screw you need. They just want to know how many more screw you need. You already used up 240, right? So just subtract 240 from 320. The rest is 80. So you need 80 more screws, and that's the answer. Any question? Here is another example. Okay, now first of all, what is the base here? Is it unknown or you know it? Which one is base? 60, right? So the right answer is C. What is rate here? Of course, 20%. Rate is probably very easy to identify, right? Because that followed by a percentage sign, right? Which is A. And the portion is of course unknown, right? So we don't know the portion. Now we have all these formulas. Now which one we should pick, because we don't know the portion, right? Which ones we will be picking? The last one, right? Because the portion is at the left side, which is unknown here. So that means to get the answer we have to multiply base times rate. We know the base, we know the rate, right? Now let's try here regarding the answer. How do you get the answer? 20% of 60, right? So all you have to do is P equals to base time rate, right? Your base is 60 and rate is 20%. Remember, again, as I said, we plug it as a decimal fraction. So I wrote 0.2 for 20%, which will be 12. So the right answer is 12 here, right? Or that will be the portion, right? Now look at this example. It's a little bit different than the other questions. Now tell me what is base here. What percent of 50 is 75? What is base here? Base is actually 50. So 50 is actually base. That's the tricky part. As I said, remember, most of the people think the portion will be always lesser. That's not true, because in this case, you see the portion is 75, which is even greater than base. Okay? So most of the cases, the base is followed by of, the word of, most of the cases. As we know from there. So 50 is your base, so the right answer is B. And 75 is the portion, which is A, and your unknown is what? Rate. Now we have the list of formulas here. Which formula we are going to use? We are looking for rate, right? So we'll be using C, which is portion by B. I'm saying the portion by base. So if I do that, what would be the answer? We'll be writing portion by base, right? So we are doing 75 over 50, which will be 1.5, right? But we have to convert it to percentage, because this is like a fraction, decimal fraction. Once we convert it, we move the decimal point 2 positions to the right, which will make it 150%, right? So the right answer is actually A. Is that right? A? Let's look at another example here. 25% of what number is 40? So what is unknown here? Yeah, the base is unknown, right? So the right answer is B for this part. Now, what formula we are going to use out of these four? We don't know the base, right? So we'll be using B, right? Because that's the formula for the base. Your base is at the left side. Now what would be the answer here? We are looking for the base, right? So the base is portion by rate your portion is 40 and the rate is 0.25. If you just do this, 40 over 0.25, it will be 160, right? The right answer is C. Okay, now we look at some problems called tolerance problem. In engineering discussion, since most of you are in some sort of engineering, so you will see equipments come with some tolerance limits, okay? And most of the cases they were written on the devices or equipments. They say, oh, it's 5% or it's 10% tolerance limit. That means whatever it is, it can tolerate 5% of, let's say if it is a register, it can tolerate 5% more or less. If it is something which can take the voltage, I'm saying everything is connected to the power, right? So it is using the voltage, it's using the current, so they have some sort of tolerance. You cannot give like, huge amount of current which it cannot take. So it can give you, it can only take like 5% of what is written, 5% more or 5% less. That's called a tolerance. Okay. Now some equipments have 10% tolerance, some equipments have 5% tolerance. Sometimes you might find 20% tolerance, but it's unlikely that it's more than 20%. But in those questions, since the tolerance is represented as a percentage, those problems are also percentage problems. If we understand percentage, this is a good time to see those problems. Now, again, just from the percentage, we know we can find the maximum limit or the minimum limit, okay, of anything. Let's say if we have a register and it's given that, okay, this register can tolerate 5% more or 5% less. So there is written something, and you have to find what is the maximum it can tolerate and what is the minimum it can tolerate just based on 5%. The information you are given, right? Now let's look at an example here. Let's say what is the guaranteed value of a 27 kilo ohm. This is a register, and which has a 5% tolerance. Now again, 5% means what? 0.05 as a fraction, right? Decimal fraction. What I do is I multiply the resistance. Since this is 27 kilo, now what is kilo? 1,000, right? So I just plug these three zeros, make it to 27,000, and I multiply by the fraction, which is actually the percentage, 0.05. Now once I do that, here I got 1350. Now if I add 1350 with the base, I'm saying whatever I am given as a resistance, I get the maximum. If I subtract it, I get the minimum. So all you need to do is to find this value, okay? This is also called the nominal value, okay? So you just find you need to find the nominal value just by multiplying the total by the percentage. Once you know the nominal value, you will add it with that, with the base value to get the maximum. You will again subtract it to get the minimum value. Now once you know the maximum and minimum, you can tell that, okay, this is a register which is 27 kilo ohm, but it can work within this limit, meaning like from minimum to maximum, it can operate correctly within this limit. If it is more or less than this range, then it may not operate or may not give you the right result, or it may, get burned out or destroyed. So let's look at some examples. So most of the cases, the tolerance limit are sometimes tolerance limit are given as this format, in this format, like plus minus 10%. That means this is the tolerance limit. Now can you find the nominal value here? What is the nominal value? What is the nominal value? Because if I know the nominal value, I can always add and subtract to get the maximum or to get the minimum, right? So remember, to get the nominal value, what I do, 250 feet times 10%. Now remember, I'll write 10% as a fraction, right? Which will give me 25. Now all I need to do is, this is in feet, right? All I need to do is add 25 to get the maximum, subtract 25 to get the minimum. And that's what I did. I just added 25 feet. So the maximum value must be D. Why not C? Because C doesn't have the unit written. Remember, everything in engineering discussion comes with a unit, right? Without the unit, that's like nothing to us. So the D is the right answer because we wrote the units. 25 is not a number, is it? Just, you have to tell 25 feet. Because you know the difference between 25 mile and 25 feet, right? That's huge. So it's important to write the unit. So right answer is D. And similarly, if you want to get the minimum, all you need to do is just to subtract, right? Again, what do you subtract? 25 feet, right? So the right answer is C. You are subtracting 25 feet because, once you know the nominal value, all you have to do is just add it with the base to get the maximum, or subtract it from the base to get the minimum, right? Any question here? We'll look at some quiz question for sure in pause after the lecture, so we'll have some more practice there. Let's look at this example. Again, this is a similar example. So, how do I find the maximum? Now, sometimes you can do the complete thing on the same formula because all you are trying is, this is your base, and you are multiplying these two to get the nominal value, right? That's what you do, right? To multiply these two. This is actually your percentage, which is 5%. 5% is what? 0.05, right? Multiplied by the base, which gives you the nominal value here, and that is added to get the maximum. So the right answer is B. I'm saying it's showing you that you can do the whole thing together, right? Now what is the nominal value here? If you multiply 0.05 times 200, how much you get? It's 10, right? If you multiply 0.25, 0.5 times 200 meter, is what, 10 meter? So actually your nominal value is 10 meters, so you probably will get 210 meters as your maximum. What will be minimum? If you subtract that value, right? Meaning 200 meter minus 10 meters, which will make it 190, right? So the right answer for the minimum is D. Okay. Anyone has any question for the tolerance? If not, we'll stop this part of the presentation here, and we can go to the quiz section and finish all the quizzes we have for this chapter 4. Okay, the percentage problems.